Very exciting.
Shall I go for it?
I think you should go for it, Mr. Haas.
I'm just going to go through our normal protocol here, if I may.
Please do.
So I'm looking for the X-intercepts of this rational function. Of course, that is where you cross the x-axis, and at that moment in time, y is 0. So I could just set this guy to 0. Shall I do that?
Yeah, because you're saying when is y 0?
That is exactly right. So my x-intercepts are when y is 0. Now, of course, this is a fraction. I know how to make a fraction equal 0.
It's when the numerator equals 0.
Well, it's really all I have to worry about. 0 over anything, that's just 0. So I want to know what makes the top 0. This is going to be a pretty easy one. I'm thinking a -2 for x.
You're,
that top 0.
You're right.
Did that in my head. What do you
Very
think?
well done.
Sometimes you're going to have to factor this, of course, but this is a pretty straightforward one. I can just see whatever x value makes the top 0, I'm all set. So my x-intercepts are, I'm sorry, it's -2. I'm going to graph that as I go.
Very good.
Let's call that -2 right there. The y-intercepts, I probably shouldn't have said intercepts. You know why, Miss Stewart?
I think that if you have more than one, you don't have a function.
That's right. You can only cross the y-axis at most one time. So the y-intercepts, I'm going to just change this back to a y. That is, of course, when x equals 0. Right? X-intercepts, that's when y equals 0. Y-intercept, that's when x equals 0.
Makes
If I
sense.
fill in a 0 for all my x's, I get 0 plus 2, that's 2. 0 plus 0, right? I'm filling in zeros for x's. Minus 4. 2 over -4. I think I can simplify that a little bit. That is a -1/2. How about that?
Very nice.
-1/2.
That's where it crosses the y-axis.
That's why they call it the y-intercept.
Isn't that cool?
That's what I'm thinking. So that's -1. Let's call this -1/2.
Very nice.
And again, there can be at most one of those. So now I'm just going to look for the horizontal asymptote of this thing. Now, the horizontal asymptote, that's called end behavior, really. That's what the function does when x goes to infinity or when x goes to -infinity. So I'm just thinking about what happens when x gets really, really big in the positive infinity direction, or when it gets really negatively big. I never know what, can I say negatively big?
I think I know what we mean, yeah.
So, you know, this is an old hat right now. I'm just looking at the controlling terms. I'm putting in a big number for x. So obviously the bottom is going to be way bigger than the top, right? It's like 1,000,000 over 1,000,000 squared, or 1,000,000,000 over 1,000,000,000 squared. Hey, the bottom is getting way bigger than the top. And of course, that means I'm approaching the value 0.
That's right. Something small divided by something huge is 0, or
That's
pretty
right.
close
And actually,
to 0.
if you even want to think about dividing an x, if I can really get rid of an x from each one, if I get rid of an x on top and x on the bottom, what am I left with, Stuart?
You're left with 1 over x.
So you can simplify it like that if you want, if that helps you out. And if I put in big numbers for x, now it's even easier to say, well, 1 over 1,000,000, 1 over 1,000,000,000, I'm approaching 0.
Yeah.
So my horizontal asymptote is y equals 0, which is, of course, the x-axis. So if I sketch it, it's right on top. Can you see that kind of dashed line there?
I think so.
It is right on top of the x-axis. That is the line y equals 0. My vertical asymptotes, well, that is where the function is undefined. I'm not allowed to cross the vertical asymptotes. You can't cross the horizontal asymptote.
That's right. In fact, you do in this one.
Yes, I do. I mean, I've got a point right on it.
Yeah.
So my vertical asymptotes, that's just what makes the bottom 0. What makes this guy 0? I think I'm going to have to factor that. Can you do that one in your head?
Well, if you do enough of them, you can. But
okay.
yes.
So I'm good. Yes, you're very smart, Miss Stewart. So what did you tell
I
me
think
about?
you can do it in your
Well,
head
I
too.
think I could probably figure it out. So you want to help me factor this
Let's
one?
do maybe 4 and 1.
That sounds good.
And a plus 4
I'm
and a
thinking-
minus
yes,
1.
that's what I'm thinking as well.
Okay.
So what makes this 0? Well, if x equals a -4, or if x equals a +1,
Yeah.
x equals -4, x equals +1. By the way, how many vertical asymptotes can you have?
You could have as many as you want to. You
could
could have an infinite, or you could have none.
You certainly could, but thankfully we only have these two.
Yes, that's
-4. 1, 2, 3, 4. And a +1 right there. I'm going to erase this. Let me just excuse me for a moment.
That's quite all right.
I'm getting rid of some clutter there. All right. All right, so I have x equals -4.
That's where the function is
vertical asymptote.
undefined.
I'm not allowed to hit that line.
Right.
X equals +1. I'm not allowed to hit that line. Now I'm ready to draw a picture.
Have fun.
Shouldn't be too bad. I gotta hit this point. I gotta hit that point. It's not really much to go on, is it?
No.
Except I know that I have to continue in this direction, and I'm not allowed to hit this vertical asymptote. So I've got no place to go but down. I mean, it's gotta
Why
go.
couldn't you go up there, Mr. Haas?
Yes, that is a good question. Well, I know I'm only allowed to hit the x-axis at the x-intercept, this one place. That's why it's convenient to have the x-intercept. So I'm not allowed to go up. I'd have to cross it again. I'm only allowed to hit it just that one time.
Makes sense.
Yeah. So now the question is, does it go up like this, or maybe it bounces off and goes down?
Ooh.
What are you thinking?
Gosh, that's a tricky one.
Well, I mean, I'm guessing it probably goes up here, but I don't know. Let's pick a point just to make absolutely sure.
Good idea.
So if I pick -1, if I pick -3, the x value -3, here's -3. If I fill in the -3 for x, will I get a positive or negative out of this top part?
In the numerator, you're going to get -3 plus 2. That's going to give you something negative.
Okay, I'm putting in a -3 and I get negative on top.
Okay.
If I put in a -3 on the bottom,
That gives
that
me
gives
a
me a
9. Minus 9.
Yeah, that's 0, I'm thinking.
Minus 4. Ooh,
Minus
that's going to give
4.
me another
That gives me a
negative.
negative. Negative over negative is positive. I don't need to know what the value is. I'm just doing a little sign analysis here. So I know that at -3, this function is positive. It must be above the x-axis. It must have positive y values.
Very nice.
So I know that I must be going uphill here and approaching positive infinity as I approach the x value -4. Is that working for you?
-4. Yeah, very nice.
Not only that, you know, I kind of know this is not one of those double root things. You know, like when
Oh,
we did
double
polynomials,
roots.
yeah, you know how sometimes it bounces off? I think we're going to do one of those next. But when it bounces off, you will notice that you get a double root. You would get this particular root twice. You know what I'm saying?
Interesting. I know what you're saying.
Yeah, and you'll see one of those next. So now, here's my function. It goes up like this. Here's what I got so far.
Very nice.
It must exist here someplace. I don't know if I'm above or below. I'm just going to pick a point.
Yeah, we can do what we just did before.
I'm doing it again. I'll pick a 2. If I
Okay.
stick in a 2, you still got me, mister?
I still have you.
All right. I'm just going to put in a 2. 2 plus 2, well, that's
Something
positive.
positive.
Put in a 2, so that gives me
4 plus
plus
6.
minus 4. Well, I'm sure that's some positive value. So I'm thinking over here at 2, it's positive. I must be above the x-axis. I must go up to infinity like this. And approach the x-axis as y goes to infinity in this direction.
So as x approaches infinity, your y is approaching 0 in that direction.
Yes, did I say that wrong?
I can't remember, but anyway, that looks
so
good.
long ago.
I
All right.
know.
Let's pick one more point over here. Am I above or below? So I will pick, I don't know, I'm going to pick -10.
Why
I could
not?
pick anything over here. I could
Yeah.
pick -100
You could.
if I was really feeling, you know, feisty. or
Feeling
something.
feisty.
But
All right, let's do
I'll
-10.
put in a -10. -10 plus 2, well, that's definitely negative. -10 squared, that's 100.
100.
Well, I can already tell what I'm going to get here.
Minus 30, minus
minus
4.
measly 4. Well, that's definitely going to be positive. Negative over positive is negative. So that means I'm down here.
Huh.
I'm below the x-axis.
Neat.
I must go off to negative infinity in this direction. And down to the y value, negative infinity.
Very
as I
nice.
approach the horizontal asymptote. So I have 3 pieces to this function. Here's one piece. Here's the other piece. It's a nice looking function.
It is a nice looking
Yeah.
function.
And here's the last piece.
Beautiful.
And that it's a sketch. It's a sketch. But this is pretty much what it looks like. And again, as always, you could put this in your calculator now and it would look pretty much like this.
Although sometimes the calculator gives you kind of an ugly thing. It's hard to see.
It does.
So it's nice to be able to know what it really looks like without relying on your
So
calculator.
again, this is I could be more accurate if I picked more points, or I could plot actual points. But this is just a rough sketch.
Feel my darkness go.